types of space agencies and how it can be different types of space agencies, and they are going to provide the data for all the customers. That is fine. But how it is related to Google Earth Engine? Now, Google Earth Engine has done one unique application, saying that all these space agencies, whatever the sites we have it here, they provide the information in the form of a parcels in the sense one particular area, one image. So like that, all the images are combined to form, and wherever we want a specific area, so all these websites like ISRO Bhuvan, USGS, NASA, USGS, and Canadian space agencies, we can download the data on parcel basis. But coming to the Google Earth Engine, we have a flexibility to get the information for entire world at a time. Means we can derive the parameters like pressure, we can land cover chain detection, all such type of parameters in a large scale for entire world. So that's the work which Google has done it. So Google provides the entire, I can say it like this. Google provides the information of entire world. If we are interested to obtain it for entire world, we can get it. Or else if we want to get it in a parcel in a specific area, like if we are interested to go to obtain the land cover of Bangalore, then we can get it. So this is what Google has done. So Google has done this, and it has mosaicked all the images. Okay. So if you see the Google catalog, so this is Google Earth Engine. If you just, only thing is you need to type in the search, just type it as Google Earth Engine. You'll get Google Earth Engine, just select it. Once you select it, you have different types of data related to that. So you have a Landsat series. You have a Landsat is related to NASA's USGS satellite series. So you have different types of Landsat series. We have a MODIS. So the Landsat, all the images. So we have Landsat 8, which was working from 2013 to present. Landsat 7, 1999 to present. Landsat 5 was working from 1984 to 2012. So like that, we have huge amount of data that is actually acquired by the satellite series. So we have MSS is multispectral scanner. So different types of Landsat series images are already archived in the Google Earth Engine. So that's the reason why it is named as a Google Earth Engine. So these are we have different types of satellite data. And the next one is that we can see what sort of applications they are going to be implemented here. Okay, so you can just see the data sets for. So we have different types of data sets. So if you just click here, view all the data sets, you can get all the data sets related to spatial information. So you can see all these data are available here. Only thing is we need to use that particular data for specific applications. I'll give you 2 applications today in today's class if possible, or else I'll cover only one application. So we have a different types of, this is the data catalog. So you have a crop inventory data. We have a DEM. We have a DEM of raw samples, all digital elevation models. We can have an oil palm plantation classification. All these things were derived from the existing data sets. So the data sets are nothing but the images acquired from a specific satellite sensor. Okay. So Landsat is a satellite. Multispectral sensor is a sensor. Okay. So a satellite comprises of a sensor. So I don't want to go in detail of it. I just wanted to tell that vast amount of spatial information is available. Only thing is we need to extract that particular information by using different methodologies and then use it for our applications. So you can see it here. So we have a Sentinel data. Sentinel is it consists of multispectral imagery. Sentinel series. It has a DEM. It has a aerosol index. It has it is ocean and land cover estimation, earth observation, full resolution, high resolution images. So as I told you, multiple spectral instrument, MSI they call it. Like that, all the data sets do exist here. Now, how we can process, how we can access this data and process this data? Only thing is, we just go there, register. If you are for the first time, just register here, click by sign up. Okay, so you have to log in. Already I have registered through my Gmail account. So you have to log in through your Gmail account. So just log in through Gmail account, and once you have logged in Gmail account, so I have just wanted to tell you that once we have a data and we want to extract the information, we can do it by doing two methodologies. One is through programming by using Python programming, and second one is by using Java code editor. So Google Earth Engine provides the flexibility for both the things. So in this case, you just consider this particular case study. You can just go to the platform, select code editor. Once you select the code editor, this is where we will get the entire platform where you can do coding simultaneously to extract the required information. Okay, so in today's class, as I told you that the first application which I am talking about is to have a NDVA. So NDVA is nothing but normalized difference vegetative indices, which is meant, in a large scale I can say that it is meant to identify wherever the greenery is there, wherever the forest is there, it appears in full green color, means we are only interested on the green cover on the earth surface. So that can be obtained. This is derived parameter from the existing satellite image. So what satellite image we are going to consider is MODIS. I will tell you. So there is a small Python, there is a small Java code, the code which is written in Java here, to obtain the normalized vegetative indices. So compute normalized difference vegetative indices. Is given as the spectral reflectance of that particular area in red band. So we know operating frequencies, operating wavelengths of this particular bands. One is 620 to 670 meters, 70 nanometers. Another one is 841 to 876 nanometers. And that particular digital number is code
sir,
here.
Voice is not continuous, sir.
Okay.
Sir, Arun sir.
Sir, am I able to use that?
Yeah, but it's not continuous.
Sir, am I audible now, sir?
Yes, sir.
Sorry, sir. Yeah. So that we are going to compute this NDVA, normalized vegetative indices, in a given area through satellite images, whether there is a greenery or not. So this is where we have used a small code. So what we are doing here is first load the image that is taken from the MODIS satellite sensor series. Compute the NDVA by using the small function that is image.normalized difference is the function. No need to worry about what complexity of this programming, because already we have lots of examples there. I can just show you the examples. So just see the functions, that's all. So what it is saying is that it is trying to obtain the spectral reflectance in band 2, that is band 2 is NIR, and the spectral reflectance in band 1, and now you pass this function such that it computes the NDVI value. And then once the NDVI value is obtained, the 0 value is represented as minimum and the 1 value is represented as a maximum, okay, because it's a fraction. So we have a minimum value is 0, indicating that there is no any greenery. Maximum value is 1, indicating that there is a greenery. Now this, then we will be using a color palette showing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different colors varying from 0 to 1. Okay, so this is how we will be just using a small Java code that can be used to compute the NDVI from the satellite images obtained from the Google Earth engine. Okay, so I'll just show you how to compute this. So here I think you can see the screen now. So here is the code which already I have shown it to you. I don't think that it is visible to you, but that's the but I have shown the code already to you. So the same code, whatever the code I have used it here, the same code it do exist here. I'm using the same code. I'll just show you how it gives NDVI. Okay, so first thing is you need to just go to the new and create your file. Already I have created a file. You can have your own folder. In that particular folder, you just create a file and start coding it there. Okay, yeah. So my program here I have used it as a NDVI. So already I have created a file and I have saved this particular code, and this is how it appears. So when you can zoom in and zoom out wherever it is required just by pressing this. So if you are interested to see the NDVI in India, you can just move to the part of India. Part of India, then goes to the so I'm interested in part of India. So just go to this particular area. Now, right, so you just, so where from I can get the code for NDVI? So already lots of examples are there. When you scroll down, you have examples here. So you have all the examples. If you want to derive NDVI, you have a code here. If you want to derive precipitation, if you want to derive pressure, if you want to derive all different types of parameters, there are already existing code for each one of the application. So you can have a pan sharpening, reduce the region, so normalize the difference. This is where. So this is where actually I have obtained this particular code. So it's already inbuilt function. Sir, I am from CSE background, I am from civil background, I am from mechanical background. I want to have a spatial data. I don't know Java coding. No need to worry. Already existing template and syntax do exist in Google Earth Engine code editor. Only thing is you need to modify it according to your requirement. That's all. So no need to worry about shall I start writing coding from the basics? Not required. Not required. Okay. So already templates are there, and then you can just run that particular template and get the output. Now just I'm clicking it here. This is the code I have written it here. So what I'm doing, I'm just see here, I'm calling the Modi's data. I'm calling the Modi's data by using a function ee.image, and that particular image, on that particular image, Modi's comprises of 32 spectral bands, out of which I am considering only 2 spectral bands. One is red band, other one is near infrared band. So only those bands are passed as an input to compute as an input to the function called normalized difference, that is used to compute the color palette. Okay, so we have a different color palette that generates from different types of, the color in the sense it starts from the basic what you call dry color, and then for one it represents it in a green color. Okay, so we have so minimum value is 0 and maximum value is 1, and the color palette consists of the different color shades. Okay, so when you run this, you can see here. See here. So wherever there is a greenery, I'm just removing the base image. That is the original satellite image taken from MODIS. This is the original satellite image taken from MODIS. And that is where we have a, you can have for entire world. So this is for MODIS jet. So on this image, from this image, we have derived the NDVA. So just to overlay NDVA on this particular image, and you can see wherever greenery is there, it appears fully in green color, and wherever there it is dry, it appears in the gray shade. So we can use different types of color palettes to see the vegetation in the given images. Okay, so that is where we can have a one sort of application. And now where to save this? So to save this particular thing, we can export, because it is entirely related to Google. So whatever the application, for example, the NDVA which you have generated here, if you want to save it, you can save it in your Google Drive. Okay, so I have just have one example, that is Landsat data. Yeah, I'll just show you how to export it. So small function is used to export the data, that is this one. So when we have a, say, we have small function, export dot image to drive. So whatever the image you have it there, for example, NDVA, that image is called here, and then it will be exported to the drive. So we can export .img to drive, and then it will be stored in the drive. Okay, so just when you run this, so your task will be active here. So the Landsat image which you have taken it here, so this particular Landsat image, so I am trying to download SRTM. Earlier I have downloaded Landsat image, and that particular Landsat image can be seen it in your drive. Just go to your Google Drive. Just go to your Google Drive. So this is the image. So it will directly store in the Google Drive. Okay, and then you can right click, download it. Already I have downloaded this particular image. I will just show this particular image which I have downloaded, Landsat image, through one of the software, that is QGIS. No need to worry about this particular software. You can just, either you can open it by using your JPG also. So just go to the downloads. So this is the Landsat image which I have downloaded it. Add and close. Right. So yeah. So this is the image which I have downloaded it from Google Earth Engine. So what I have done here is what I have done in the sense, Google Earth provides a platform to obtain different satellite images of our area of interest. We can process it by using two things. One is by using Java coding. Other one is you can do it by using Python console also. Just you need to have a software, and just a Python program is there. You just run this particular thing. You can obtain both of them in your Python, in your platforms. Yeah. So this is how you can do the programming. The flexibility provided by Google Earth Engine is that you can do programming. You can process the satellite images by considering two things. One is through Java coding, other one is Python coding. Don't worry about the coding, because already there exist lots of examples. Only thing is we need to know what sort of application we want to use, and then immediately you save the output in your drive, and then you can share it to anybody. Okay, so I just wanted to share this particular information, because if we know this such type of what sort of application we want to implement, there is no deficiency of data. Lots of data is available through Google Earth Engine, because they have consolidated from different space agencies. So if those faculty at this moment, I request, if you are interested, we have a lots of requirement on spatial data extraction and processing, and we can take real-time projects. So at this moment, I thank the CRI and the management of KSRM College of Engineering for providing an opportunity to share my ideas with you on Google Earth Engine.
Thank you,
I
sir.
thank. If you have any queries, please ask participants. I request you to please ask the questions.
Sir, can we identify sand-rich locations, sir?
Sir,
Can we identify sand-rich locations or sand-rich points?
Standpoints means, sir?
Sand-rich, అంటే ఇసుక సార్, ఇసుక ఉన్నాయి
Yes,
కదా.
sir. So it is like this, sir. We have a satellite images which are basic information. Which is the basic data, and now we can use different types of indices or else different types of fractions, so that finally they will help us to identify only sand pines.
Okay.
Even sand pines, even we can go for glaciers. We can go for only mountains. We can go for only rivers.
Yeah.
So wherever rivers
Yes,
are there, we can extract.
Okay, it's a mining also we can see. It's a depth.
Yes, sir. Yes, sir. That's the what you call that is the wide variety of applications we can get it through this Google Earth Engine. In fact, Google Earth Engine doesn't have any what you call role in sending satellites and getting the data, but it has created a consortium of different space agencies.
Sir, resolution, sir. Can we?
Sir,
What
the
is the
best
resolution, sir?
which we can get is which it is openly available is 5.4 meters, sir. Means
Okay.
1 pixel covers 5.4 meter square area.
Okay.
It is open source.
Okay. Thank you, sir.
Sir, any queries from participants? Yes, sir. Okay, sir. Thanks to Dr. Arun Kumar, sir, for sharing his knowledge on the Google Earth Engine. I thanks all the participants for attending this faculty lecture series. So we stop this session up to now. So we join tomorrow at the same time. Thank you, sir. Thank you and all.
Okay. Thank you, sir.
Thank you, sir. Thank you very much, sir.
Okay.